Welcome friends. In this video we are going to discuss about indeterminate shafts. So what are indeterminate shafts? So as we have discussed in case of indeterminate beam also, that whenever we are unable to calculate the number of reactions by our static equations, जो static equilibrium equations है उनसे हमारा अगर number of unknowns नहीं निकल पाता है, we will call that as an indeterminate condition, that we are unable to solve that particular condition. Then we use the compatibility equation. Okay, so in case of beam we used to use the delta values. Delta of the whole shaft we used to that as 0. Here we will be using theta values. That theta of the whole shaft will be 0 because both ends are fixed here. Okay, so let's say I am having this shaft AC and there are two loads. There is basically a couple acting on it, couple of P at point B, such that the distances are, this is 3L by 4, okay, and this distance is L by 4. There are these two distances. Now I don't know what will be the reaction at A, what will be the reaction at D. How do I do that? First I am going to convert this into a torque value. Okay, तो ये किसके ऐसा हो जाएगा लगभग कि ये मेरी शाफ्ट है, okay, and on this shaft I am having a torque acting over here, and the direction of torque will be, if you see from this side, it will be clockwise, and value will be P into D. Okay, तो P into D का एक torque इधर लग गया, right? Torque at B is equal to P into D, right? And now I don't know what will be the reactions at point this and this point, so I will simply assume the reactions here. Okay, I am going to assume the reactions. Let's say this is my reaction torque T at A, and there is a value of T at C, and I don't know the value. So first is to do the static equilibrium. Static equilibrium will give me TA plus TC is equal to PD. That is my first equation. Okay, and how do I write the second equation? I will say that theta of this whole shaft, that is AC, will be equal to 0, which means theta AC is equal to theta of AB plus theta of BC, right? And theta AB plus theta BC, and that is equal to 0. Now I put the expression of these two thetas, and theta का expression अपना क्या होता है? TL divided by GJ. Okay, so on that particular section of length L, whatever is the torque that is being applied, and GJ are the properties of that shaft. Okay, so I'm going to put these values here for AB and BC part. Right, so what will it become? AB, for AB the torque is acting TA. Okay, so it will become TA into length is 3L by 4, TL divided by GJ. I have not mentioned anything about GJ here, so I will simply assume that the GJ is constant throughout the shaft, that plus in the same direction I am going to take the torque, that will be TA minus PD, okay, divided by GJ, again the same value, into length is L by 4 only of this particular section is L by 4, and this is equal to 0. Okay, so what I will get here, it will give me 3 times TA plus TA minus PD is equal to 0. Okay, and if I solve this equation, that will give me TA is equal to PD divided by 4. That is the value of T. If this is TA, what will be the value of TC? TC will be 3PD divided by 4, because the summation is PD. Right? The summation is PD. So from this equation I will get TA is equal to PD by 4 and TD is equal to 3. TC is equal to 3 PD by 4. Now I need to calculate what will be my maximum stress acting over this shaft. Okay, so on this shaft from A to B the torque is acting PD by 4. From B to C the torque is acting 3 PD by 4. So what will be the maximum shear stress? Maximum shear stress will be with respect to TC, right? So tau max is equal to T, what is the value of this? TR by J, right? We write the value like this. So I will put T, torque that is acting in this area BC, that is 3 PD by 4. So 3 PD by 4 into radius is what? D by 2 into J, that is pi D4 by 64. Okay, so the maximum shear stress value is nothing but how much will this become? 24 P divided by pi d square. Okay, so 24 P divided by pi d square. Sorry, this is 32, right? We are going to take the polar this value here, so this will become half of this. That is going to basically 12P divided by pi d square is my maximum shear stress value that is getting generated in this shaft. Okay, so I have calculated the reactions based upon my compatibility equation and my simple static equilibrium equation, and I have calculated the maximum shear stress that will get generated in this shaft. Okay, now in order to elaborate this, let's take one more example where the diameter of the shaft is constant but the concentrated torque on it is changing continuously. Okay, so let's assume that there is a shaft here and the shaft I am simply representing by line, क्योंकि दो लाइन खींचने doesn't make much of a difference. Okay, there is a point A, there is a point B, C and D. Okay, the torque acting over here is 100 Newton meter. It is 400 here and it is 100 here in this direction. Opposite direction, the value is 100 and all the lengths are L only. Okay, the lengths are L only. So this is my B, this is my C, D and E. Fine. The diameter that is given to me is 40 mm here. Okay, the 40 mm diameter of the shaft is there. What I need to calculate is what will be my tau maximum value. Again, I need to calculate the maximum tau value. So in order to calculate maximum shear stress on this shaft, I need to know what is the torque value acting on individual parts here. Okay, and in order to calculate the torque value, what I need to do, I need to calculate the reactions acting over A and B. Okay, now A and E, sorry. So let's assume that there is a reaction at E, TE in this direction, and there is a reaction at A, TA in this direction. Okay, so first time what I will do, I will write the static equilibrium equation. The static equilibrium will give me TA minus 100 minus 400 plus 100 plus TE is equal to 0. Okay, so this is basically giving me that TA plus TE is equal to 400 Newton meter. That is my first equation. Okay, what will be my second equation? I will write the compatibility equation. So compatibility equation will give me theta from A to E is equal to 0, and that can be written as theta AB, theta BC, theta CD plus my theta DE. Okay, I can add all these values. So finally, when I put them into the formula, what I will get is I will be getting theta AB, that is TAL divided by GJ. GJ is constant throughout the shaft. Okay, plus theta BC is TA minus 100 into again the length is same only, तो L by GJ. ठीक है, CD के लिए क्या हो जाएगा TA minus 500 right into वही L divided by GJ plus DE part के लिए क्या हो जाएगा TA minus 400 divided by GJ into L, and this is equal to 0. This whole value is equal to 0. Fine. So what is the value of TA from here? If I solve this, then I will get TA. TA is where 4 times there is TA, so 4 times TA. Okay. What was this? Minus 100, minus 500, and minus 400. So that becomes 1000. 1000 it will become, right? So minus 1000 is equal to 0. That gives me TA is equal to 250 Newton meter. Okay, TA की जो value अपनी that is 250 Newton meter here, and if TA is 250 and TA plus T is 400, so TE will be equal to 150 Newton meter. Okay, सो दिस इज माई फर्स्ट स्टेप, आई हैव कैलकुलेटेड द रिएक्शंस हियर, ठीक है। अब मैंने रिएक्शंस निकालने हैं, देन आई नीड टू नो कि इन विच पार्ट हाउ मच टॉर्क इज एक्टिंग, ओके। तो आई विल डू द टॉर्क डायग्राम हियर, आई विल मेक द टॉर्क डायग्राम हियर। सो इन ओके, तो ये अपनी साथ थी, ये दोनों मैंने रिएक्शंस यहाँ पे कैलकुलेट कर लिए हैं 250 एंड 150। अगर मैं इसका टॉर्क डायग्राम बनाऊंगा, ओके, तो आई एम अज्यूमिंग दैट दिस इज माई 250 पॉजिटिव साइड, okay, from here to here, from point A to B, it is going to be 250 only, okay. From B to C there is a 100 in opposite side, so it will become 150, okay. So it is 250 here, it will become 150 here, right. Then there is a 400 opposite side, so it will become what, minus 250 on opposite side, so it has become minus 250 here, right. And after that there is a 100, so it will become minus 150 finally, and that is our torque diagram, okay. So from this torque diagram I can say that maximum torque value Tmax is equal to how much, 250 Newton meter, okay. So जो shear stress आएगा मेरा maximum, which is basically TR divided by J, okay. और we usually also say that it is 16T divided by pi d cube also, ठीक है। तो यहाँ पे मैं T की जगह क्या डाल दूंगा, 250 न्यूटन मीटर डाल दूंगा, फाइन। तो इसकी वैल्यूज यहाँ पे डाल दो, तो दैट विल बिकम 16 इंटू 250 न्यूटन मीटर डिवाइडेड बाई पाई इंटू डी क्यूब। डी कितना था हमारा, 40 mm था, राइट। तो 40 इंटू 10⁻³ क्यूब, ओके। सो दैट विल बेसिकली गिव मी 19.89 megapascal. That will be the value of my maximum shear stress on the given shaft, ओके। तो एक अपना ये हो गया अभी, ठीक है। एक नेक्स्ट केस ले लेते हैं। नेक्स्ट केस में क्या करेंगे कि द डायमीटर इज वेरिंग एंड द टॉर्क इज वेरिंग, ओके। बोथ थिंग्स वी आर गोइंग टू अप्लाई हियर, फाइन। तो आई एम हैविंग द केस वेयर देयर इज डायमीटर ऑफ दिस शाफ्ट, okay, and the diameter has changed. So when the diameter change, our J value will change, okay. So because of the J value, shear stress will change and theta will change, all those values will change. This is my shaft, okay, fixed at both the ends, fine. Now when the shaft is fixed at both the ends, and these are my points A, B, C and D, lengths are L only, all the lengths here are फाइन, ठीक है। तो इसके ऊपर जो मेरे को टॉर्क दे रखा है, द गिवन टॉर्क आर, देयर इज अ टॉर्क वैल्यू T एक्टिंग हियर, ओके, एंड देयर इज अनदर टॉर्क वैल्यू T एक्टिंग एट पॉइंट C, ओके। सो देयर इज अ टॉर्क एट C and there is a torque at point B. What I need to calculate is I have to calculate the reactions here first, okay. What will be the reaction at A and D, and what will be theta of B with respect to A. Or simply in question it may be mentioned that what is theta of B, okay. Then we will need to calculate the theta of B with respect to A or theta of B with respect to D, any point, okay. So in order to calculate the reactions, I am going to assume that there will be a TA here and there will be a TD here, okay. And then I write the first equation, which is obviously the static equilibrium, that is TA minus T plus TD is equal to 0, means TA plus TD is equal to 2T. That is my first equation, okay. Second equation I will write from the theta. Theta of AD is equal to 0 because both ends are fixed, and that is equal to theta of AB plus theta of BC plus theta of CD, okay. Now I put all these values, okay. So these values will give me theta from A to B is TA into L divided by GJ, okay. So let's say this is my J1, this is J2, and this is again J1 only, okay. These two shaft portions CD and AB are having same diameter, so TA L divided by G J1 plus theta BCC के बीच का it will be TA minus T into L divided by J2 plus theta CD, that is TA minus 2T, right? TA minus 2T into L divided by GJ1, okay, and that is equal to 0. So if I take the TA common from here, so it will give me TA into 1 upon J1, 1 upon J1 from here and 1 upon J1 from here. So it is basically 2 upon J1. Okay, so TA 2 upon J1 plus 1 upon J2, 1 upon J2 from here, and that will be equal to T upon J2. Right, it will be T upon J2 plus 2T upon J1. Okay, that is my second equation. Now I can solve these two equations in order to calculate the TA value and TD values. Both I will get from here. Okay, so what it will be, यहाँ से अगर मैं T कॉमन ले लेता हूँ इसमें से, तो दिस विल बी हाउ मच, 1 upon J2 plus 2 upon J1. Fine, and these two will cancel each other and TA is equal to T. Okay, TA की वैल्यू हमारी T के बराबर आ गई है. अगर TA की वैल्यू T है, then from this equation I know TD will also be T only. ठीक है, तो TA is equal to T and TD is equal to T. Now when I need to calculate theta A B or theta B with respect to A, I will simply say कि ये हमने ऑलरेडी यहाँ पे कैलकुलेट किया, तो दिस इज माई थीटा बी विद रिस्पेक्ट टू ए, यानी कि टी एल अपॉन जी J1 इज माई थीटा बी विद रिस्पेक्ट टू ए. ओके, तो लेट्स से दिस इज अवर लास्ट केस जहाँ पे अपना द टॉर्क इज यूनिफॉर्मली डिस्ट्रीब्यूटेड ओवर द शाफ्ट ए बी. ओके, तो आई एम हैविंग दिस शाफ्ट ए बी एंड द टॉर्क इज यूनिफॉर्मली डिस्ट्रीब्यूटेड सच दैट इट इज T Newton meter per meter at the end of length L. Okay, so if I say the height at any general x, okay, so on any general x, the height of this distribution will be how much? Tx at any general x divided by x is equal to T divided by L, right? Because it is uniformly distributed, triangular distribution है, तो Tx is equal to T into x divided by L. This is my the magnitude of distribution at any point. Now if I need to know okay, what will be the torque value at this element which is at a distance of x. Okay, so first I need to write the reactions here. Okay, so the first reaction, let's say it is TB. Okay, second reaction at this point, let's say TA. Okay, there are two reactions. So based upon the reactions I can write the static equilibrium equation that will give me TA plus TB, because both are in same direction, minus whatever is the concentration of this particular distribution, that will be T into L divided by 2, because it is a triangle, right, is equal to 0. So this is basically TA plus TB is equal to TL divided by 2. That is my first equation for the reactions. Okay, I need to write another equation also, but in order to do that, because I will need to do theta AB is equal to 0. Okay, and theta from this point to this point will be varying. That will be varying based upon the torque value at any x. At whatever is the x, the value of torque will give me theta with respect to that element. Okay, so this Tx value, if I balance this much part, okay, this much part only, so that will be something like this. ये अपना जो है एलिमेंट है जिसकी मैं बात कर रहा हूँ. ओके, एंड ओवर दिस एलिमेंट फ्रॉम इन द लेफ्ट साइड एनी वन साइड आई कैन टेक देयर इज ए TB value here. Okay, and then there is a this torque, distributed torque is there, and distributed torque value will be T into x by L, that was the height. Okay, into x by 2 because area of the triangle. Okay, and that will give me the reaction on this element, that is T at any x. Okay, so finally what I am getting here is the torque at that particular element is nothing but Tx square divided by 2L minus TB. Okay, that is the value of my torque at that particular element, and if this is the torque value, okay, I can say the theta of this element, this particular element only, theta which is equal to TL divided by Gj, so T into L divided by Gj, right, and Gj is a constant because it is same material and same diameter. Okay, so that will give me tx is this value, tx square by 2l minus tb divided by gj into length. What is the length of this element? I am considering an element of length dx. Okay, so into dx. That is the theta of this element only. Okay. Now, if I need to calculate theta of this whole shaft, that is theta from A to B, that I can say integration of this element. Okay, and this will give me integration from 0 to L, from initial point to final point of tx square divided by 2l minus tb, divided by gj into dx. Okay, that I am getting here. Now finally I can write it as gj is constant value, so 1 upon gj into t upon 2l, the first value, so t upon 2l into x square, and x square is x cube by 3, x cube by 3 and l cube divided by 3 minus tb into l. It will become, right? And this is nothing but 0. Okay, net theta has to be 0 from point A to point B. So this will give me TB is equal to how much? TL divided by 6. Okay, the TB value is coming out to be TL divided by 6 over here. ठीक है, एक बार चेक कर लेना, अगर इंटीग्रेशन वगैरह में भी कुछ इशू तुमको लगता है तो जस्ट recheck it and re-verify it. Okay, if TB is TL by 6, then TA will be how much? TA will be that I have already written, TL by 2 minus TA, यानी कि TL divided by 3. That is my the reaction at point A. Okay, so both the reactions I have calculated. One is TL by 6, another is TL by 3. So what will be tau maximum? Tau maximum is how much? Based upon the reaction values only I can tell. Okay, at this point the torque value is TL by 6. Okay, and at this point the torque value is TL by 2. Fine. So what is the maximum value of torque? That is TL by 2 only. So tau maximum will be with respect to TL by 2. So this will be equal to nothing but TL divided by 2 T 16T divided by pi dt. Okay, so that is my maximum torque value. So I can say that my tau maximum is coming out to be not TL by 2, it is TL by 3. The reaction is TL by 3, right? So it is coming out to be 16 TL divided by 3 pi dq. That is the maximum shear stress value at acting on this particular shaft that we have taken. Okay, so well, that was all about the indeterminate shafts. So now indeterminate shaft we have completed, and with this this topic of shaft gets completed. It is finished now. The next topic that we are going to consider, that we are going to discuss, is regarding Mohr circle. Okay, so Mohr circle and principal stresses relationship that we are going to discuss in that video, and I will be explaining the derivation of all the formulas based upon Mohr circle. So basically, if you understand how to use a Mohr circle, you will be able to write all of the formulas related to principal stress, maximum shear stress, plane of maximum shear stress, plane of maximum principal stress, plane of zero shear, plane of anything you will be right once you will understand the Mohr circle. Okay, so that we are going to take in next video. Thank you for watching the video, and best of luck for your exam.